Hi, in this tutorial, we're going to look at the spur gear parameters available to us in Fusion 360. In order to get to the spur gear tool, you'll have to come to Tools, and under Tools, click on Add-ins, and when this comes up, when you click on Scripts and Add-ins, come here to Add-ins and click on Spur Gear and click Run. Now, the first parameter that comes up inside this tool is called pressure angle. So let's talk about what that means. Basically, the pressure angle is the angle between the tangent line, which connects to the center of the radius of the top arc of the tooth of the gear, and the tangent line that is touching the inner circle of the gear. And so if you take these two lines and you draw an angle between them, that's the pressure angle. So you can see here, this is 14.5 degrees because the angle right here of this line that's coming right through the center of the radius of this arc is much smaller than the one of this arc, meaning that this arc radius is smaller than this arc radius. The larger it is, the smaller the angle, because this circle gets larger, which makes this line get come closer and closer to the blue line. And so the main thing to remember is that a larger angle means that the tooth is thicker and stronger, because a larger angle means that there's more material inside the tooth. Now, that's at the expense of more gear wear, because you have a longer face for the tooth to rub against. Now, if you make a small angle, then the tooth is weaker because the tooth has less material in it. But there's also less noise and there's less surface contact for that reason, because if the tooth is more at a straight up angle, if you will, then that means that there's less surface contact. But if the angle is really extreme and coming out a lot, then there's going to be a lot more rubbing because it's a longer face. So here we're going to look at diametral pitch. And so what that means, it's basically the number of teeth per inch divided by this diameter. Now, the main thing to remember here is that the diametral pitch changes the diameter of your gear. So that's the main takeaway of this. Now, yes, there is this proportion, the number of teeth divided by the pitch diameter, and that will change your value right here under pitch diameter. It's going to change this value, that's for sure. But the main thing to remember, as I just mentioned, is that it's going to change the diameter of your gear. And one thing to remember with the diameter of the gear, which I'd like to mention, is that the operating pitch circles need to be touching. So in this previous slide, I showed you this ring, which is where the diametral pitch is measured. This is called the pitch diameter. This circle at this particular location between the arcs right here, that's the pitch diameter. The two pitch diameters of both of your gears, when they're meshing, they need to touch. They need to be tangent to each other. That's a key thing to remember with gear design. So the number of teeth is what it sounds. It's the number of teeth. And the backlash is the distance between two teeth when you have the teeth interlocking. So one thing to remember is if you're going to 3D print the gears, then you can make your distance, your clearance between the teeth very tight. So your backlash is going to be very small. Also, if you're going to be machining the teeth of the gears, if you're going to be hobbing them out of aluminum with a very accurate process, then you're also going to be able to make a small amount of clearance and you're going to have a little backlash. But if you're carving these out of wood by hand, then you're going to have to allow more clearance around the teeth because your method of manufacturing is less accurate and it has larger tolerances. And for that reason, your backlash is going to be larger than if you created it in a more accurate process. So the backlash in a perfect world is 0. Now the root fillet radius right here, this root fillet radius is the radius here at the bottom of the teeth. Now, this radius at the bottom of the tooth, it needs to be as large as possible without touching the other tooth of the other gear at any point in the rotation of the gears. As long as it's not in contact with this gear, then you're fine. The main thing to remember is that you need to worry about your tolerances and your manufacturing process. If your manufacturing process is not creating accurate enough gears, then your radius needs to become smaller and smaller, and that makes your tooth less and less strong, because the smaller the radius, the less strong the tooth, because there's more of an ability for there to be shear there, for the tooth to actually break off of the gear. So the main thing is to just make it as large as possible within reason, within your parameters, within your tolerances, while not being in contact with the other tooth during operation. Now the gear thickness is very obvious, just like the number of teeth. It's just how high or how thick the gear is. The hole diameter is also just what it sounds like. It's the diameter of the inner hole. And that's it. Thank you.